Hello, 8th grade. Today we're going to be talking about how to simplify some rational expressions with common denominators. So we're going to already start with common denominators, which can be really nice for us. It's building off of something we did earlier with rational expressions. So I'm going to start again with what a rational expression is. So a rational expression, when you see that, you should see the word ratio right here, which of course means it's going to be in the form of a fraction. So it is something on top of something else, and an expression means it's going to have variables. So there's some variables in here, maybe an x and a y and a w and a smiley face, my favorite variable. And that's what a rational expression at its heart is. So what I want to start with is a review of what we can and can't do with rational expressions, and the big thing is we cannot divide by zero. We cannot divide by zero. Can't happen. So if we look at a rational expression, for example, I'm going to use, 3 divided by 5m. If I can't divide by 0, then whatever's on bottom cannot be 0. And if it can't be 0, then 3 over 5m. What's on bottom is the 5m, so I say 5m equals 0. To figure out what I can't do, dividing both sides by 5, I get m equals 0. So that's what makes the bottom 0, which again cannot happen because we cannot divide by 0. Very important, very bad thing, don't do it. That means m cannot equal 0. Which I know is kind of strange to say here, m equals 0, and then go to m does not equal 0. But our goal this whole time was to figure out what m does not equal. And we did that by setting the bottom here to 0, solving for m, and then saying that's what it can't be. So we're all good to go there. And I want to do one more example here, and that is 5m divided by m plus 1. So this is a separate example. If you would like to pause the video now and see if you can do it by yourself, that'd be a great idea. And then I will show you all how I will do this. So looking at this, we want to look at this bottom number, and we say we cannot divide by 0, so that can't be 0. So I want to figure out what m is to make that 0. So I'm going to say m plus 1 equals 0, which I know is strange. That's okay, because we just said this cannot equal 0, but we're going to write it as equals 0 so we can play with it a little easier. If m plus 1 equals 0, I can subtract 1 from both sides and get that m equals negative 1. And then I can say that m cannot equal negative 1. And that right there would be my answer. And that's just ways to figure out how exactly we're supposed to approach this problem, because this tells me that I cannot set m equal to negative 1. No matter what else is going on here, if I have m equals negative 1, there's a problem. So moving forward a little bit, I want to look at how we've simplified some rational expressions before. An example I'll use is going to be 8h squared over 12h. And the way we'd simplify this would be to say I have 8 over 12. I can take out a 4 from both of those. So this would be 4 times 2h squared over 4 times 3h. Or I can just divide both of these by 4, however you want to look at it. And after doing that, I get that that is equal to 8 divided by 4 is 2, h squared. 12 divided by 4 is 3h. Very cool. And this right here, these cancel out, and I end up getting 2h squared over 3h either way. Just two different ways to look at canceling out parts of fractions. So looking at this 2h squared over 3h, I can now divide both the top and bottom of this by h, because they both have an h in them, and what that's going to get me is 2h divided by 3. Another way to look at this is that up here I have h times h, and I can cancel these out and get 2h over 3. So those cancel, and my answer here is going to be 2h divided by 3. Let's do one more so that y'all can look at how this is done. And if you'd like to pause this would be another great one to see how you can do it before watching me do it. This is going to be 25x cubed divided by 10x to the negative 1. So I know this is a bit of a stranger thing because we have a negative exponent now. That's all right. Here I have 25 and 10. I know I can divide both those by 5, so that's what I'm going to do first. Divide both those by 5. And what I end up with is going to be 5x cubed over 10x to the negative 1. Sorry, not 10x. 10 divided by 5 is 2x to the negative 1. And then looking at this, x cubed divided by x to the negative 1. That's kind of strange. What I'm actually going to do here is to just get rid of one of the x's. So I have an x on top and on bottom. I just want one either on top or on bottom. Generally, I'm going to try to make all of my exponents positive. So I'm going to find my negative exponent right here, negative exponent, which is the same as the positive exponent above the line here. So I can switch what side it's on to change the sign of the exponent, and that's going to become the 5x cubed stays in the same place, the 2 stays in the same place, but to make this a positive exponent, I'm going to move it up top. So if you look here, this x moved from the bottom to the top, and this became a positive 1 instead of a negative 1 on the bottom. And after that, x cubed times x better be x to the 4th, and I have 5x to the 4th divided by 2. And that is a lot of the review that we've done. I know that's taken up a majority of the video. That's okay, because the concept we have today is to simplify them with the same denominator. So the first one I want to look at is going to be b over a cubed minus 2b over a cubed. So looking at this problem right here, I should be thinking to myself, there is a common denominator. That's nice. And then thinking, how do we subtract fractions? Because I have subtraction here. The answer is I don't like to subtract fractions, so I'm going to do that. Just change that sign from negative to a positive. Let me do that in a different color so you can see what I did. Change that from negative to positive and make that negative 2b over a cubed. What I can do now is if we are subtracting fractions, I just keep the denominator. So that's a cubed, stays the same. And on top is where I do the subtraction. So now this is going to be b plus negative 2b. And b plus negative 2b is going to be negative b divided by a cubed. And that is how we simplify that rational expression. I have a bit of a trickier one for y'all. And I'm going to write that down in fuchsia. It's a great color. And we will do p q to the negative 2 minus 7 divided by p to the negative 1 q squared. And looking at this, they don't have the same denominator, which is sad. They're different. Makes me sad. But if we look a little bit closer, we might actually be surprised. So if we're simplifying these, it's generally nice to try to make the exponents positive. If we make all the exponents positive, it'll be a lot easier to figure out what's going on. So by making these all positive exponents, my p is already positive, it's good to go. My q here has a negative exponent. So what's going to happen to it is it's going to go below the fraction, and the exponent will turn positive. So now this is q to a positive 2. Have my subtraction still. 7's good to go. My q has a positive exponent already, so it'll stay. But my p here has a negative exponent. My p has a negative exponent, which means I'm going to want to bring it up top. And when I do that, I get p to the positive 1. P to the positive 1. And now looking at this, I have q squared on bottom and q squared on bottom. So these are the same. So now we are very happy with that. There's a common denominator that makes our lives a lot nicer. And what we're going to do is to combine these two fractions because they have a common denominator, and we can do that. And what we're going to get is p minus 7p divided by q squared. P minus 7p is going to be negative 6p divided by q squared. And just like that, we are good to go. That's as simplified as we can get, so we're going to stop right there. I'd like to give you guys one to try by yourselves as well, which is going to be 7a b to the negative 3 plus 2 divided by b cubed a to the negative 1. And if you guys solve that, should be fairly simple to solve. I'll let you guys pause the video now and try it by yourselves if you'd like. When I see this problem, it doesn't jump out at me right away that we have a common denominator, but that's why we have to make sure that we get all positive exponents to make sure that we can compare these better. So this b has to move to the bottom. So we get 7a divided by b cubed. Again, this negative exponent means it has to move. When it changes sides of the fraction, the exponent changes signs. Then plus 2a, same thing happens to the a there, divided by b cubed. And this is a lot like the last problem. We have a common denominator, divide by b cubed. 7a plus 2a is going to be 9a over b cubed. And just like that, we are done, which is really nice. Kind of as a last thing, I want to wrap up with what we reviewed today was how to finding impossible values, which was where we had to divide by 0. Those are bad. What we also looked at today was simplifying rational expressions when we're not adding or subtracting them. And then today we added and subtracted. I'm going to use a plus and a minus sign because that's a lot of letters. Add and subtract rational expressions with a common denominator. That is a whole bunch of shortening there. If you'd like to write the whole thing out, that might be better. But this is what we went over in the video today, how to find our impossible values, simplifying some rational expressions, and then adding and subtracting rational expressions with a common denominator. And if you don't understand these, I'd encourage you to watch the video again. If after 2 or 3 times you're still not quite getting it, write down some questions and ask them during class, and we will be good to go. Other than that, I will see y'all in class.